downward, concave down, generally. There's always exceptions and special cases. All right, number 2. So they want us again to graph here this log function. So let's give it a try. So let's make a couple observations. Here's the first thing I want you to know. Whatever number, the number that makes the inside of a log parenthesis, right there. I'm not saying that very clearly. The number that makes the inside equal 0. So what number? That'd be 2, right? If you plug in 2, it'll make the number that makes the inside of a log parenthesis equal 0. The number that does that is the vertical asymptote. So that's going to be at 2. There's the vertical asymptote. That's important to find. And then when we start to make our XY table, we want to plug in numbers. 2's not going to work. So you could try it if you wanted to. But if you plug in 2, it won't work because it's y equals log base 3 of 2 minus 2 plus 4. That's going to be log base 3 of 0. And the log of 0 is an error. So that won't work. So then we go up from there. So that tells us where we start. We go up from there. So let's plug in 3. So y is log base 3 of 3 minus 2 plus 4. And what's that? That's log base 3 of 1 plus 4. Now, how do we do log base 3 of 1 on our calculator? We don't have a log base 3 button. Well, this is where I'm going to give you a special formula. It's called the change. Here, let me change the color while I write this. It's called the change of base formula. And it says that anytime you have the log base b of a, you can write that as log of a over log of b. You can make it into 2 logs. It's called change of base because, so this is 1 log and these are 2 logs over here. And both these logs have a base of 10, don't they? Because they're not showing their base. Remember, whenever the base is invisible, it's really a base of 10 with the normal log word. If you have ln, that one has an invisible base of e. But if you have the normal log word with an invisible base, the base is 10. So we just changed the base. Log base b became 2 log base 10s. 1 log base b just became 2 log base 10s. It's called the change of base formula. I'm not going to prove it, but you can prove it easily. It's a true statement, and we use it a lot to solve logs. And here's the deal, because we can do these on our calculator. Those are just regular logs. We can hit the buttons. Whereas this one, we have no log with a base of b or in this case base 3 or whatever. We don't have a button for that, but we change it. And notice the way it goes. The base one goes to the bottom and the other one goes to the top. And that makes sense, right? Base is always on the bottom. So the base to the bottom. Okay, so let's do that over here. So the base to the bottom, the log 3 goes to the bottom, and the other one is on the top. So 1 log becomes 2, and you still have the plus 4 out there. Now, why we do that is because now you can hit the buttons on your calculator. Now you can type log 1 divided by log 3, and it'll be 0. 0 plus 4 is 4. So that's the point over 3, up 4. Now we've got a log point. Okay, let's get one more. Let's go one higher. Let's plug it forward. Now remember, we started at 2 because that's what made the inside 0, and we went up from there. Now we've got y equals log base 3 of 4 minus 2 plus 4. What does that give us? Log base 3 of 2 plus 4. Remember, so now we do the change thing here. We don't have a log base 3 button on our calculator. We just have a regular log button. So we make that into 2 logs. Remember, the base goes to the bottom always. The other one's on the top. So if you hit the buttons on your calculator, what you'll get for that first part, this first part right here, is some weird decimal. I'll do it right now as well. Log 2 divided by log 3. I'm getting 0.63. Then you add the 4. You're going to get 4.63. I'll just put 4.6. Now that's a valid point. Over 4, up 4.6. It's about right there. But it's not a point we can really use on our graph because we can't click the exact spot. It's a decimal. So we need another one. And we have to be kind of smart about this. How so? Well, what's going to give you a nice, easy point is to pick a number that you plug in that makes the inside the same as the base. So what could I plug in for x to make the inside be 3 like the base? 5, right? If I plug in 5, see what I'm going to get here? Let me come over here. I'll do it up here. If I plug in 5, I'm going to get y equals log base 3 of 5 minus 2 plus 4 log base 3 of 3 plus 4. And remember the trick, when you get the log of a funny base, you make it into 2 logs. The base goes to the bottom. The other one stays on the top. And I don't need a calculator for that. Log 3 over log 3 is same thing over itself is 1. 1 plus 4 is 5. Do you see how that worked nicely so I get a whole number answer? So that's what we do. So over 5, up 5, right here. Over 5, up 5. So on the graph making tool, you just select the, right there, the horizontal, the vertical asymptote, and then the 2 points 3, 4, and 5, 5, and it makes this graph automatically for you, this log graph, and this goes down, forever, getting closer and closer to that line forever without ever touching it. Now they want the domain, the range, and the asymptote. Let's come down for the asymptote. That is going to be easy to find. The asymptote on this one is going to be x equals 2. Right? The vertical asymptote hits the x-axis at 2. What's the range? Remember, the range is like the up and the down. The range is how low the graph goes and how high the graph goes, from bottom to top. So the graph goes from negative infinity to positive infinity. It goes down forever and up forever. Last question, what is the domain? Kind of doing these in backwards order. The domain is how far left the graph goes, and then comma how far right. It's left, comma, right. So how far left did this graph go? Well, it goes to 2, and it doesn't quite touch to the 2. Remember, this piece of the graph, this log piece, comes down closer and closer forever to that dotted line at 2, but it never touches it. You never touch a vertical asymptote. So I'm going to put a parenthesis by that 2, not a bracket. Remember, brackets mean you're straight on the number. You hit it, but we don't hit the 2. All the way to infinity. It goes from 2 to infinity, left edge, comma, right edge. There's the domain. So notice the domain is from 2 to infinity. There we go. Let's try this one, number 3.